Hello. Hi guys, good morning. I know there is some issue. I have been trying to figure out why is that the case. But if it's still occurring for you guys, then please just let me know. Like a buffering kind of issue will come in meanwhile, thoda bahut, but please bear that because I cannot resolve it from my end. It's just OBS will just show. But yeah, before that, can we please smash hello Arvind, hello, yeah, hello, hi everyone. Like firstly, just make sure that like you write down how many questions you guys did, how many questions you guys tried, and how many questions you were able to do. And for sure, can we please smash that like to 15 likes? That would be super great. 15, yeah, like you guys come daily, we have it daily, so why not? Let's have it done. We'll quickly start it. Aryan Sharma, hello भैया सिर्फ दो हुए यार, no worries. Third one was actually very standard and easy, so matlab not sure if you have done LIS, so it should be very like the problem statement was a bit confusing, but after reading a few times you should be able to solve. Like you should have been able to actually recognize it's actually a LIS problem. But yeah, Akash 404, like great, that's it. We have seen the problem of digit DP twice in the last contest, and in that itself we had gone on the variety, or you can say, because digit TP follows the standard code, you need a position, you need a tight, and accordingly maybe you need a sum, remainder, whatsoever remaining, like odd, even, anything extra. And for sure leading will come in, as in when I say leading I mean leading zeros, because you need to maintain okay leading zeros has started or not. So that is entirely we have seen previously in the last two contests as well. Still, if you don't know how to solve problem of digit DP, go and write on YouTube digit DP by Aryan Mittal. You will see two contests and a problem of digit DP itself to actually go and solve it. But yeah, today also we'll see. But yeah, that is a very standard concept and problem of digit DP. Cool. 2 Bharat, Arvind, Aryan, Pushkar, Kushagra, Shubham, Ashutosh, Akash, brother, thanks for the digit DP which you have taught. Thank you so much, Akash. Abhay 2 4, as always, sad AF. No worries, solve 1 2 and 4. Okay, that's a great thing. But yeah, can we please smash that? See, you guys are 31, right? And for sure you must be the previous usual audience of ours, right? Then why not? If you are the usual club, then just smash it and let's reach 20 likes. That would be super great. And we'll be starting off with the first question. It's very easy. It just says okay, go and count the pairs whose sum is less than the target, which means I have the array. I have to go and find the pairs I and j, where I is less than j, such that the sum of that number elements is less than equal to my target. Nums of I plus nums of j should be less than equal to my target. I'll simply go and have a for loop, which means I have a loop of I, have a loop of j. I'll go and find the sum. If that sum is less than my target, I'll simply add a count or my answer, anything I want. I can simply get that done. So I went on simply a for loop, or two for loops, one of I and one of j, for sure making sure okay my j is more than I. So with that, if I go and ask if my this sum is less than target, then simply increase my answer. That will be my answer. That is the first question. Cool. Going on to the next question. Very simple again. Make a string and see. The question number 2, it can be implemented in many ways whatsoever, but still we will just try to have okay the easiest, shortest possible code. We will see, but yeah, still the logic itself, it can be one thing, and code writing can be one thing. Code writing, it can be in different ways, but still that needs to be okay. How short we write or how long we write, that can be done. Cool. And again, apologies for having that buffering kind of, I don't know why few times my internet speed is pretty good, but by few times it just comes as red, while not few times it just comes as green. Not sure why is this happening, but yeah, I'll make sure that something happens. This is my first ever Leetcode contest, solve two problems. That's great, Supratam. Make string a subsequence using cyclic increments. Now what it means is I have having a string s, string 1 and string 2. Now in an operations, I can select a set of indices in string 1, and for each index I in this whole set of indices, and that can be any locations, I can increment my string 1 characters by the next character, which means if it is a I can make it a B, which means I can increment the characters of string A, which means string 1, to actually more characters, which means if it is A, I can make it a B. If it's actually a Z, I can make it a A. So now what I want is, I want the K to return true if it is possible to make string 2 a subsequence, mark my words, a subsequence of string 1. The operation I can apply is make the string as A to B in string 1, B to C in string 1, and that operation I can apply only once, only at most once, which means at most once I can apply. Maximum at max I can apply at most once. Now coming on back, I can apply this operation at most once, and in string 1 I have to apply this operation. I want to make my string 2 a subsequence of string 1, which means ultimately if my string 1 has these many characters, and string 2 has, let's say, only these characters, so all these characters should for sure lie in my string 1. And to achieve these characters, of string 2 inside my string 1, the operation I can apply is choose this character and increase this character by 1. Or I can ultimately also say that, okay, if it is actually a B and here it is a A, so operation I could have applied is increasing this A to B. Or I can also say, okay, what I will do is decrease this B to actually a, and I will just check if A is here. Oh, I am good. Okay, I can just apply this operation and I can decrease, and I can just match, okay, A and A is here. It's just that, okay, string 1 you can increase it, string 2 you can just vice versa say, okay, I can just decrease it. So this B I can decrease it. Aryan, what if it is B and it is also B? Cool, that is also work. That also works for us. Why, Aryan? Because you need to decrease, right? So you must be saying, okay, B decrease to A and then compare. No, when I say if both the characters also are same, one option is, okay, I can just decrease the character and will just match the decreased character. Or I can say if the characters are same also, then still it's a good thing. Why? Because as simple as that. Why it's a good thing? Because I'm saying, okay, I can choose a subsequence of characters, which means I can even skip this, and I will just say, okay, I did not modify my string 1 and increase it, so for sure I can just skip it. With skipping itself, because subsequence is something which you can skip also, with skipping I did not choose this particular character to increment it, and I can just skip it and still it matches with my character. That is the reason, okay, I can just skip the characters itself. So I'll just try greedily and try to match the nearest character possible. What I will do is, okay, I will just go and try, let's say the first character, let's say this character is C, and let's say this character is let's say F, and let's say here it is E. So I'll just go and try greedily. Let's say I found a B here, so I'll go, okay, let's say if I found a B, okay, for B and B found, let's go on to find a C, or maybe go and try a B. Next I'll go and try, here I got a A. No, that's not actually a B, neither a C. Cool, no worries, I can keep on going. I'll try this character with actually a C or a B. Okay, so let's imagine it is also still not here. Cool, I can just simply skip it. Here I found a C. Oh, I have a C also. Cool, I can simply use this. I can move it to the next character. I'll go and try for F or a E. If any I found, okay, I'm good. I'll go and try. Okay, here is neither a F nor a E. Cool, no worries, move ahead. Here it's a F or a E. Okay, I found a E. Cool, move ahead. Cool, I have exhausted my string 2, which means, okay, cool, I am done and I have found the answer. That is how you can simply go and greedily check. Okay, if I have got it, cool, simply go on to next character, because for every character, for this character of string 2, you have two options. Either you can maintain that or you can decrease that. Why we have two options? Because in string 1 we had option to do a subsequence. When I say subsequence, I can choose, let's say if the subsequence, is B, C, D and E. Now when I choose a subsequence, let's say choose a subsequence as B and D. So when I choose it, I'll reduce this to A and this to C. So you will see, okay, these got decreased, but this remains same. It got decreased, it remains same. So in one operation, I can just decrease it, okay, but yeah, I can also take the same elements which remain the same, and that's how you can simply get this solved. Although still it has many ways you can implement it. Now other ways it can be, I can simply go on in the string 1 and can increase that element or even match that same element with string 2. Here we went on to decrease the string 2 element. You can also go and increase the string 1 element and compare with the latest element of string 2, and can keep on comparing until you reach the end of string 2. Or maybe let's say if you are at the mid of string 2 or maybe any position not end of string 2 and you have exhausted your string 1, which means it's not at all possible to actually make this string 2 a subsequence of string 1, so you can simply return a false. So again, I said there are many ways. Either you can compare directly your string 1 with string 2, or you can compare your string 2 with string 1. When I say compare, I mean, okay, you can compare your string 1 with string 2 by increasing the character of string 1. By increasing character of string 1, which means if it's a B, I can increase that to C. Okay, it's an increase operation, right? Increase operation. So I can increase that to C. Now I can just simply compare, okay, if the B or C, anything compares with this character, you can simply go on to the next character and try for the next character. Try for the next character. And that's how you can simply keep on going. Again, if I just got this, I can compare if they are same, or maybe C, or if I can increase it, maybe if the D is same, still I can just get that done. So simply anyways, or you can simply say, okay, I'll just use string 2, maybe I'll decrease the string 2, now I'll compare with string 1. That also you can actually do it. With this you can easily get this solved. Still again, the code can be pretty long and pretty short. One of the shortest code which you can actually see is this one. But yeah, before that, can we please reach 25 likes? That would be super great. Yeah, you guys are like janta yaar, purane ho, to why not? Can we reach 25 likes? Just 4 more. That would be super great. So what we did was simply going on to all the characters, getting the current character. Now again, here I just saw just a condition that, okay, if the character is a, now what I am doing is simple, going on last, which means I'm decrementing my string 2 characters. If it's a B, I'll try for B and I'll try for A, which means one decreased character. But what if it's a, so I'll try for the decreased one, which is actually a Z. So if it's actually A, try for Z, or else you can try for the previous character, which is the C-1. Now again, what we can do is we can actually go on in the string A, and again I'm just comparing. I have one pointer on string 2. I'm going on to string 2. I'm comparing any character. If I got for string 1, I'm good. So I'll go and try for the string 1. If I have not found a C, or I've not found a T, C is this character and T is the one decreased character. If none of them I am finding, I will keep on incrementing my I pointer in my string 1. As soon as I find any of the character, either a string T or a string C, I am good to say, okay, I have found a character, I have found a match, simply go on next. But what if I have exhausted my string? So I can simply return a false. But if not exhausted, I know, okay, I have found a match between this character or this with the ith character. So simply increase my ith pointer to the next pointer of string 1, and that's how you can simply get this solved. You will simply keep on going until you find all of these characters of string 2. I'll simply go on to all the characters of string 2. Anyway, in any between I got stopped, I can simply return a false. Again, I'm saying it can have a any numerous implementations of the same concept, the concept behind remains same, that you greedily go and check if actually you are matching that. And why greedily works? Because you are concerned about the subsequence, and for sure the previously, if anything comes, anything matches, then later I will have many more options to explore for the next characters. That's the reason greedy would work for sure. I can simply return a true. Cool. We quickly go on to question number 3, but before that we'll actually have a quick chat read. But yeah, before that, can we please smash that like baby to 35 likes? That would be super great. Just 4 more likes, that would be super great. Cool. Smash. Thank you so much, Abhay. This is my first ever Leetcode contest. Also solved 2 problems. That's great. Mr. Negative, count pairs, vector, nums, integer. I have never seen this argument in C++ 11. No, that's normal. That's normal in C++ 11. Solved 1 of 1 2, no worries. I thought 4 problem easy, but it gave me TLE. TLE should not come because it depends on the number of arguments we are taking in actually our digit DB. But yeah, there is no more arguments you can take. It's just position or like the index. It's just a tight variable. It's just the other extra variable, let's say help or sum or remainder. Every of these numbers come in the range of 10 to 20. Or in this you have odd and even as the other variables, and other one most variable is leading zeros. So all the variables still combined will actually be 10 into 10, 10, 10, 10, 10, 5, 6 times 10. So it will be a 1is6 algorithm. Still, that would be more than sufficient. So it should not have given a TLE. But no worries. Third to samajh hi nahi aaya. Yeah, that's the reason. Third, if you understand what's happening, it will be very easy. But if not, then the question explanation or the question example itself will be actually a bit complex. But yeah, cool. We actually see it. Sorting 3 groups. Now, what is mentioned is sorting 3 groups. Cool. It seems like it's a haunted place. Cool. Sorting 3 groups. Now, what we are said, please understand this very carefully. It's a very easy problem. I'm just saying, okay, I have the numbers from 0 to n minus 1. Now, all the numbers, which means let's imagine I have the numbers 0, 1, 2, 3, 4, 4. Let's say I have these 5 numbers. I have divided all these numbers into some groups, into groups of 1, 2, 3. Now, when I say, I will just say, okay, this number is actually of group 1, it is of group 3, it is of group 1, it is of group 2, it's of group 3. And now I stated this, let's say groups, where the number I belongs to the group nums of I. Now with this, you will see that, okay, it is one particular array, it is another array. That's just a simple representation, right? But it is saying, okay, it is not an array. It's actually the indexes of this particular array, nums of I, right? It's an array nums, while the number actually are the indexes, right? It is just what we saw here. Cool. Notice that a few groups can be empty as well, which means it can be happening, okay, number 2 never even appeared in my answer itself. So group 2 is empty by this particular case. But still, let's imagine this is the case. Now, what I am allowed to do is I am allowed to perform this operation any number of times. What operation? Operation is pick a number x. Now the x number is this number, right? Now, and change its group. What I can do is I can pick a number, I can change its group, which means if the number is 3, I can change the group to 2, or I can change the group to 1. Anything I can do, I can choose to do. Now, if what, why, and how to do it? Simply, more formally change the number x to any number from 1 to 3. I can simply change any of these groups, which means any of this number of the array, to any other number. Let's say I change it to 1, or let's say I change it to 2. Anything you take. Cool. The new array result is constructed using the following procedure. Now, I need to construct a new array, and how that new array is made, which means this new array result is made by simply sorting the number in each groups independently, which means I will just grab all the numbers independently of every group. So for group 1, let's say G1, when I say 1, I will just grab all the indices. So I'll grab a 2, I'll grab a 0, and I'll grab nothing else. For group 2, I can, and see, these are 2 numbers, 0 and 2. For group 2, as you saw earlier, I changed the group 3 to group to group 2. So this number 1 will actually be now in a group 2. Now for group 2, another number is 3. Now for group 3, number is actually a 2. Sorry, a 4. So now, okay, I have got all these numbers individually of group 1, group 2 and group 3. Now I was said is sort the numbers in each group. And for sure, I just collected all the numbers from starting to end, which means for group 1 I collected the numbers from starting to end. And for sure, you know that the numbers are the indexes. Indexes are always already sorted in this order. So indexing are always and already sorted in this order. So I grabbed the numbers in this order, so it's already sorted, no worries. Now it is said append the elements of group 1, group 2, group 3 in this order itself, which means I will just say group 1 elements, group 2 elements and group 3 elements I will append in the same order. So this is the final list which will be made, which is actually the result array. Now it is said that to make the array nums is called beautiful array if the constructed result array is sorted in the non-decreasing order, which means this result array, it should be sorted in the increasing order kind of stuff. See, whenever I read a non-decreasing, I interpret that as an increasing because I cannot understand non-decreasing. It's maybe my mentality of what God knows, but I cannot understand non-decreasing. I always understand increasing. So even if I just say okay by myself, increasing with same values or like this. But yeah, whenever you read non-decreasing but I am saying increasing, mean that okay, increasing with the same values. Cool. Now it is actually increasing. So ultimately my task is okay, it should be increasing, right? Now we will backtrack what was happening while we were making this particular example. Now I know that if I am actually making this particular array in the last, you will remember, okay, it was a group 1 element, it was a group 2 element, it was a group 3 element. Now I am having the indices of these. So you saw, okay, all these indices should be together, all these should be together, all these should be together. But here you saw, is it actually a increasing one? No, it is not. 0, 2 and then 1, so it increased and then decreased. So okay, that is actually not a correct transformation which we did to convert this number to 2. Now why is that the case? What was missing? Aryan, what was missing? Firstly, you will see, okay, all these are the indices, so these will for sure be unique. Ultimately this result array which will be made, it will have all the unique values, and because these are all the indices of the groups. Now for these indices, what we want is actually the groups, but the groups are actually the numbers, and these numbers we can transform. So ultimately if I know, okay, the group 1 will have all the elements, group 1 will have all the elements. So if anyway I say, okay, my number 1 is actually in group 2, let's say I just say, okay, my number 1 is actually in the group 2. So what will happen is this number 1 will go in the group 2. But if I just say later words, this number 2 is actually in group 1, so this number 2 will go in group 1. So no matter what, if I will append these numbers, 1 will come after 2. So what I will do is I would want, okay, this number 1 should come first and number 2 should come next. Why? So that, okay, the groups will be forming 0 and 1 and the groups will form as 2 and 3. So you saw, ultimately to actually collect the numbers together, what I internally am thinking of, oh, the 1 should appear like this, my 1s should appear like this, and then 2s and then 3s. So actually my nums array of groups which are having only 1, 2 and 3 should actually be increasing to actually internally make their indexes, because ultimately if it is increasing, their indexes I will take also will be in this particular order of groups, which will actually always be increasing, and that's how I can simply solve it and get this done. So you will know ultimately your answer should have some 1s, some 2s and then some 3s, because you want the groups, because ultimately the groups will the groups will be appended together in order of 1, 2 and 3. So ultimately you know that okay, your groups 1, 2 and 3 should look something like this. And when I say it should look, it actually also means that okay, it can be possible that group 2 is not even there, but yeah, it should be increasing in the group number order itself. So ultimately you have reached to a conclusion that your group numbers should actually be increasing. And how you reached it? You reached it by seeing this pattern of how actually you are transforming your groups to your indexes, and then back to groups, and then back to actually the order of appending those groups. So ultimately you just came back and say okay, now the groups should be actually in the sorted order. Now your main task is if you have this particular array, which means 2, 1, 3, 2 and 1, you have to modify some of the values, which means let's say I modify this, I modify any other value, I want to modify minimum possible locations to actually make this increasing, make this entire thing as increasing. So what I want to do is, like again, ultimately my main aim is to actually make this entire thing as increasing, as I showed you. To make this entire thing as increasing. Now to make this entire thing as increasing, ultimately I just want minimum deletions. So I am concerned about making this as increasing with minimum deletions. Firstly, I just go and ask, what is currently the longest increasing subsequence in this? If it is currently this, okay, I'll just stick to that. But whatsoever remaining is there, I will just modify them. So I'll just go and ask, hey bro, what is the longest increasing subsequence with you? He'll say, bro, maybe I can take a 2, a 1, or maybe I can take a 2 or a 3. So the longest increasing subsequence actually of size 2. Maybe I can take a 1 or a 2, still of size 2. I can take a 1 and a 1, still of size 2. So what I can recognize by this is my longest increasing subsequence in this entire array is actually of size 2. Maybe I can just check maybe I can just grab the elements 2 and 3 and say it's of size 2, which means is okay, my longest increasing subsequence in this entire whole thing is actually of size 2, which means 2 is actually good. The remaining part I actually can modify by myself. What I will do is, if I say the size is 2, I can simply modify the middle elements by any value, because I know I can make it increasing anyhow whatsoever. Let's say for this example, I'll just go and ask him, hey bro, what is the longest increasing subsequence for you? Because I am very sure, okay, the remaining elements I can modify and I can increase them anyhow whatsoever I want. I'll go and ask him, what's the longest increasing subsequence, bro, for you? He'll say, okay, for me I have 1, 2, 3 and 3. The longest increasing subsequence has a length of 4. So remaining 2 elements I can modify. So it is the minimum possible deletions I need to make. It's a minimum possible deletions I need to make to actually make this entire stuff as increasing. Now for this, ultimately you internally know by your mind, if it is a 1, I can simply make it a 2 or a 1 any way I want. I can make this actually a 2. Now okay, again it has become a decreasing, but you know the longest increasing subsequence for it currently was 4. So remaining number of elements, because you know elements were 6, 4 was already maximum, which means longest increasing subsequence, remaining is a 2. So you will modify these 2 numbers and that is actually your answer also. So again, that is what you will do for this entire problem. Again, going in back, simple, it's a longest increasing subsequence problem. Simply go and find the longest increasing subsequence, come back and subtract that from your n, which is the size of your entire array. So again, you can solve it via recursion also, but I know that how we can solve the longest increasing subsequence length in O of n log n, in O of n square time, is because you know the constraints allow for O of n square very well. So I can do is, if I want to find the longest increasing subsequence, I am standing at this particular value. I will compare these values, these previous value, and also I will maintain the DP for everyone. DP at this particular I will say me the longest increasing subsequence up till this point. And for sure, if this value, let's say this value x, this value y, if this x is more than my y, I can always say, okay, I have my DP of I plus 1. Because again, I'm saying DP of I is saying it is up till ith index, the maximum, the longest possible subsequence. Now dp of I plus 1 will just say simply, if you just go on, if x is more than y, again x is more than equal to y, then I'll just say dp of I plus 1. Now when I compare, I will compare all the previous indexes, so I'll just maintain a maximum for all of them. It's a very standard longest increasing subsequence problem. So that's the reason I'm just doing it in the bottom up approach, and I'm not going the recursive, because the recursive is a very old school for this. It's not a very new DP problem, which means for which I will do a recursive. It's a very standard DP problem. So please think of it as in brute force. It will be very helpful. Sorry, bottom up, it will be very helpful. If you don't know how to solve it, again I'll just give you a very simple example of how the bottom up DP works in our longest increasing subsequence. What will happen is, at every point of time you will keep and maintain your dp of I, which will actually just say that, okay, dp of I, let's say for this I want to find what is the longest increasing subsequence at that point. I'll keep the track of maximum of current dp of I with, actually I'm comparing with the previous dp of j's. So I'll just go and ask for previous dp of j's, provided, and when I say I ask, I also add a +1, provided this value, which means the nums of I should be greater than equal to my nums of j. So I'll compare with this, everyone I can compare of. I can actually increase my dp of I, which can actually be helpful for my next future dp of i's. Cool. I'm quickly looking at the code. I'll simply go and find the longest increasing subsequence, and with that I can simply get this solved. Again, I have this dp. Initially my answer will at least be 1, because one element can always be a longest increasing subsequence for me. I'll go and simply do a O of n square longest increasing subsequence algorithm, which means I go on to every index. For every index, I'm going on to all the previous indexes, which means I from 0 to I minus 1, I'm going on to every indexes. Now for that, I'll go and check if that value is more, only then I will do a dp of I, maximum of existing dp of I plus 1 plus dp of j. And again, I'm just taking the maximum, what is the longest possible subsequence for every indexes, and I can, again in the end, I know the longest possible the longest possible subsequence is actually answer, and I can simply subtract that from my end to actually get my final minimum deletions. I want to actually make this as increasing entirely, and that was we solved. That's the reason it's O of n square. Now why this is a very easy problem, because it was just the intuition to get to know that you have to actually make this nums as increasing entirely, which means just a 1, 2 and 3 ka order, and to make this you just want this to be increasing entirely. So you just want, okay, what is the existing increasing subsequence length, which is the longest increasing subsequence length. Okay, it is right now this xyz. You can know, okay, it is longest, so whatsoever remaining, it will be the what you will modify, and that's how you can simply get this solved. Cool. We'll quickly jump on to question number 4, but before that, can we please smash that like maybe to 50 likes? That would be super great. 50, just 4 more, that would be super great. And we'll quickly read on the chat. Samyak Sun 20, thank you so much. यार पता नहीं it's of no message, मतलब it doesn't matter like ये money वाला, but यार it feels good when you guys do such a cute things, but yeah, that's not required, but thank you, Samyak, great explanation, keep going bro, thank you so much. Let's quickly read on the chat. Quickly, we'll go into question number 4. Any doubts whatsoever you have, just comment down below. That would be super great. थर्ड तो समझ ही नहीं आया. आई होप दैट आकांश अभी आ गया होगा. भैया आई डिडंट completed with DP, then is there any option to solve it without that? See, without DP, question number 3. See, firstly, if you have not completed DP, I suggest you complete or completing this. See, completing DP is nothing such a statement. Just go either, see, even if you have not understood this, or maybe if you have just watched it, I have mentioned, just go and search longest increasing subsequence by Aryan Mittal. You will get 2 videos. Just watch both of them. Firstly, watch O of n square wali, then watch O of n log n wali. Just go and just understand that. Okay, come back to this problem again, try to think it, watch this video again, and that will be solved. There is no concept like completing anything. It is always you encounter a problem and you study for that. That's it. There's no concept like, okay, I'll complete this, then I'll study this, I'll do this, I'll learn. No. Just encounter problem, learn a concept, move on. Problem, concept, move on. That's how you actually solve it. I was using map in question number 2, but was unable to solve it. Yeah, map can actually also see. You can use many data structures. There are many. Question number 2 can be solved in many ways. Tried binary search. Binary search. Binary search, I don't think can be done for this, because binary search can be implemented, okay, when it's actually increasing, and okay, maybe it's just one element which is actually wrong, but it can have many elements wrong at many locations, so you can't apply binary search. Third question, I figured out that I need to make a 1-1-1-2, but I got stuck there. What should I do? Is it lack of practice or something? Please answer as per your experience. If you still know that it's a 1-1-2-2-3-3, then it's a lack of viewing, which means yeah, practice I can say, but practice related to DP problems. Why? Because if you had seen if you had seen anything like, okay, 1-1-2-2-3-3, now you know, okay, you have to make something like this, which means you know your subsequence should be increasing. So now you know, okay, if it needs to be increasing, what is the existing increasing subsequence? So either you are missing this gap, okay, ultimately you want a increasing subsequence, or you need to collect increasing subsequence, and then maybe you can just reduce it down. Okay, find the longest increasing subsequence. If you are skipping this gap, which means if let's say if this gap of yours is being skipped, so there is some bit of a practice required in the DP end. So what you can do is just filter out on the basis of DP problems and then try for that, and primarily the standard ones. Okay, bottom up DP, just try 1D and 2D DP problems, not the ones which are actually recursive ones, but still, like, it will just come with practice. So just keep grinding and keep practicing. That would be super great. आज तो second B नहीं कर पाया, DP map पता नहीं क्या लग रहा था. No worries, Purdal, no worries. That, see, never get disappointed on any contest. Just try to learn, and see, when I learn, let's say if you miss and if you actually regret from your internal end, in just, let's say, mid of the week, let's say on Thursday, don't watch the video, just look at the problems again. Now again come back, oh, ye kaise hoga, how this can be solved, how this, if you remember exactly how this can be solved with the code also in your mind being printed essay, you are in the good directions. If in a week you forget what you have learned the last week, you need to watch the video again, you need to revise the notes again. The time you keep on forgetting what you have learned, you will keep on repeating the mistakes. The only thing which you can stop is actually, if your mind knows, okay, if I have got a concept, I should be sticking that to my mind until I have, let's say, 1 month, 2 months, or 3 months. So the concept should actually stick. Let's say if in today's video you learn DSU, you learn MST, you learn crystals, you learn that concept of include and exclude and edge. So please remember this. Okay, just go and in the middle of the day of Wednesday or Thursday, just go and ask how the DSU can be implemented. Okay, I can have the initialization where I will initialize my parent vector and the rank vector, where I will just actually go on to all the indexes and initialize my parent with actually that particular I itself, and then I will have my find where I will have my parent of I. So basically I have to return the parent of X. So basically if I'm doing a X find, so and for the folks who don't understand this, today's problem was actually based on crystals, MST, DSC, and all that stuff. So okay, for the find, I have to return the parent of X, but that can be assigned, and if I have reached the X itself, which is actually the parent, so if X is equal to parent, then simply return a X, else go and do a recursive call on the parent of X. Okay, that's my function of find. How the function of union looks like. Okay, It's nothing but again going and finding, okay, x union y. So go and find the x. Okay, I'll get a x set, y set. If I'll go and ask, okay, if both are same, okay, it's already in the same component. If not, okay, simply go and say if not in the same component, just go and compare the ranks. Whosoever rank is more, make, okay, if the x rank is less, y rank is more, make the parent of x as y. If the y rank, or else, okay, if the y rank is less or equal to actually x, just make the parent of y act as the x. And for sure, if the ranks of both of them are same, simply increase the rank by 1. So that's how, you know, okay, you just recall the entire algo by yourself while in the mid of the day, randomly you are having a lunch, okay, you recall that. So that's how you will be very fast in the algo part. Now when you have remembered it, just go in the middle of the day, okay, how Aryan was saying, okay, for a HTTP problems, what all things are required. If I want to apply, if I want to have my longest increasing subsequence, how that can be done. So keep on remembering stuff so that you don't forget that, because DSU, MST, many people can't solve MST only because of the reason, because people are not good with DSUs. So just be so good that, okay, if I ask you implement a DSU, you should be like, okay, I'll implement this right now. It should be so much frequent and so much easy to actually, okay, algos, I know, just implementation, I am solving problems for that. So that is what we need to solve. Cool. We'll quickly go on to the quickly we go on to the next problem. That would be super, but yeah, before that, can we please smash that like baby to 55 likes? Just one more, that would be super great. But the intuition and logic behind that is hard to think. Yeah, that's true, Akansh. भैया शीट के बाद कैसे प्रैक्टिस करनी है? शीट के बाद simply go and give contest, as much contest as you can give. All platforms, Codeforces, CodeShip, and Leetcode. If time, please give Leetcode virtual contest, solve problems daily. And I'll say, when I say give virtual contest, I actually mean at least one contest a day after your work. If you're not doing any of the work, or maybe not going to college, or maybe not having any side projects and stuff, then give at least 2 virtual contests along with the actual contest which happens, because you have a big day and you want to do more and more coding. Cool. Brother, DP question. Yeah, we are moving on to the question number 2827, number of beautiful integers in the range. It's a very standard question of digit DP. If still you have not figured out by seeing the question itself, if your inner mind, it did not spoke about digit DP, which means you have not been watching our videos regularly, you have not watched the last 1 month contest. In the last 1 month or around 1.5 months, we have seen twice the problems of digit DP, and these were exactly same. All the problems of digit DP are more or less same. It's just a slight difference or a slight change in how we need to find the numbers, else they are exactly same. So that's the reason. Still you have a chance. Please watch this video very carefully. But yeah, it's my responsibility. But yeah, again in the next, again on let's say Wednesday and Thursday, just remember, okay, firstly how to identify a problem is of digit DP, then go and find, okay, what all arguments are required in the recursive code of digit DP, and then just remember, okay, what all things I have studied, which means what all problems I have solved regarding digit DP. Just keep on memorizing that. And when I say memorizing, see, coding is not entirely your mind. It's actually how present you are for that problem. And that presence is never, okay, I will just have my entire seat, I will have a pen and paper, and then I will solve. No. People just look at the questions. That's what I do, and I used to do. Look, I will look at the question the entire day, because I have to work. So I have to present, I have to code down, right, in actually office and stuff. But in my mind, let's say I'm walking, I'm going to washrooms, let's say I'm just having a quick, a small talk with anyone, let's say maybe I'm free. So in my mind, I would be thinking of a problem, and that's how you just develop that problem solving. But let's say if you are at the same place trying out, then maybe you can just have a buffer. Okay, I'll try for the next 45 minutes or maybe 1 hour. After that, I will just watch this solution. But let's say if you are at work, or let's say if you are at school, you are just having, like, if you're just traveling, then in that meanwhile you can think of, you don't need exactly a pen and paper. If you need it, you can have it at your hand or maybe anywhere else. But yeah, just have a habit of thinking while you are actually working, bathing, like you are in the washroom. Just have this habit, and that will be very helpful. Cool. Going on, we'll quickly go on to the next question. We will read the comments later on. Cool. I just say, okay, I am having positive integers low and high. Thank you so much, Samyak. Again, we are having positive integers low and high and integer k. Cool. A number is beautiful if it meets both the following conditions. Now, what's the condition? That's the thing. Firstly, the number is in the range of low to high. The first hint is he's asking me for the number of numbers in the range from low to high. And again, the second biggest hint is I cannot iterate on all the numbers and verify, because the numbers are itself 1e9. I cannot iterate on 1e9 numbers. So I cannot, in worst case, I cannot iterate on all the numbers, but still I want to find the numbers from low to high. It's a very, very, very big green flag that it is a problem of digit DP. Digit DP are the problems where you need to find such XYZ numbers. When I say XYZ, I mean some numbers which satisfy this XYZ condition. This condition, it can vary a lot, but I need to find such numbers which follow this XYZ condition, and provided, okay, these numbers are in this range. Now, when we say we will solve this problem, what we will do is I will just break it down. I will just go and find the numbers in the range of 0 to high. Okay, I'll just decrease the size. It did not decrease. Okay, I'll go and ask the range in 0 to high, and I can go and ask the range in 0 to low -1. And okay, let's say the number of numbers are, let's say 100. The number of numbers, let's say, are 50, or let's say 14. So I'll just go and subtract this. I will get, okay, 86 are the number of numbers which are between low and high, and also which are between low and high and follow this XYZ condition. Now, Aryan, that's the main thing, right? To just, firstly, you know that I just broke this down to, again, 0 to high and 0 to low -1. So if I need to find such numbers between this range, I'll break it down to low, like from 0 to high and 0 to low -1, and that's how I can simply get this solved. Coming back, to even find in this range from 0 to high, this numbers, let's say 100, but you need to know, okay, from 0 to high, the numbers I am forming, it should satisfy both of these conditions. Now, what is the condition? Condition first is that, okay, count of even digits. Now, I know the even digits are 0, 2, 4, 6, and 8. Now, it should be equal to the count of odd digits, which are 1, 3, 5, 7, and 9. That is one condition. Cool. Again, here you should be able to flag one thing. It is a 0. But you would be able to only flag your 0. Now, Aryan, why flag this? I'll let you know. I'll let you know. But yeah, you should be able to flag this, but you will be able to only flag when you know that in your problem of digit DP, you need to have a variable called as leading zeros. Now, Aryan, why that is needed? I'll let you know. But still, you should be knowing one prime variable is, see, if it is a first problem of yours of digit DP, then no worries. There's a high chance you won't be able to get it entirely, but still watch this entire video and then go and write on YouTube digit DP by Aryan Mittal. You will get 2 more contests and problems for that. Just go and watch the last part, which means you will have the timestamps in the comments. Just go and watch the last question of digit DP. With this, you will just get familiar with how the problems of digit DP works. But standard, you need to have the index. Now, Aryan, why index? What index? So what you will do is, you need to get all the numbers in a range of 0 to high. Let's say my high is, let's say, a number 6935. It is my high number, which means, let's say I ask you, get me the range of numbers from 53 to actually 6935. Now you know it is a low, you know it is a high. So again, I just broke down, I will go and find the numbers in the range of 0 to this number high. So you will know, okay, I have these 4 locations to actually fill in. 4 locations are the maximum location I can fill in. Now when I say these 4 locations, I mean the indexes. Now for these indexes, I will just place an element here. So for me, I just converted this number to a string. Now it is no more a number for me. It is actually a string for me, for which I am placing some of the digits. When I say digits, I actually mean the alphabets. I am placing the alphabets at these locations. Please don't spam Deepak bhai. Please. Just try. No worries. We'll actually look at the problem. But please don't spam anything. But yeah, before that, can we please smash that like to 65 likes? That would be super great. Just 4 more. 65 likes. But cool. Now I converted this number to actually a string because I know if at max my number of digits can be 9, so I can't iterate on all the numbers. So I just converted that number to a string. So at max my number will be 9 characters. So it will be at max 10 characters in the worst to worst case. It will be at max 10 characters in the worst to worst case. So I will have at max 10 indexes to go on. Now, as I am going on to every index, I need to place a digit at that location. So one thing is for sure, you know that your variable, one variable is actually the index. Now, as you go on and place a number, it is always possible to place a 0 to actually a 9. Now, here the fun part starts. When you actually are placing a number from 0 to 9, let's say I place a number 0, right? Again, if I place a number 0, it actually indicates that the number has not even started, because if a number has leading zeros, you always know that the number has not even started. So that is a fun part. If I am placing a 0 at the first location, I actually mean the number has not even started. So one thing is for sure, I need to have a variable called as leading zeros. That, okay, am I having a leading zeros or not? Now again, what I can place here, can I place a 9 here? If I place a 9 here, any number which I will place, let's say even if I place the minimum values, still this number will be more than the value which I will have. So I cannot place any number whatsoever I want. I can only place a number up till 6. That is the maximum I can place. So what is this called? This is called as a tight. That you are bounded by the tight. That, okay, if I say I am tight, which means I am, say, okay, I should be restricted in this range. I cannot be open to all the numbers from 0 to 9. I should be restricted to have the numbers from 0 to 6 and not from 0 to 9. Cool. That is another range called as tight. Now, Aryan, why is this needed? I will always place the number from the same. If it is a 9, I will place it from 0 to 9. If it's a 3, I'll place it from 0 to 3. No. Let's say it had been a 4. So will you place every number from 0 to 4? No. Because I say it is a tight, so this tight will go and carry forward. How it will carry forward? Which means if the number is actually tight, which means if it's actually a 6, so every number after it will also be a tight, because 6 is matching my exact number. So my tight will keep on going forward. Next time I will also have a range of 0 to 4, which is also tight. But if I have any other number from 0 to 5, which means I place in any number from 0 to 5, now my range is not tight at all. I can place in any number from 0 to 9. So my tight has not carried forward, it has become a 0. So that's how you know that, okay, to actually know, okay, what element to place, you need to actually maintain a variable called as tight. And again, these two are very normal in the, which means it's a basic of digit DP, that okay, you will have a I, you will have a tight for sure. Now you understand, okay, why your tight is used, and you understand why your I is used. I is to go on to every indexes of your entire string, because you have converted your number to a string, and tight to just make sure, okay, you are just trying to experiment and not going out of bounds of actually your number. Now, cool. You have got your tight, you have got the leading zeros, and Aryan, why leading zeros? Simply to just make sure, okay, that your number has started, which means if I just ask you, can I place a 0 here? Yeah, you can place. Can I place a 9 here? You can place. Maybe not. Provided you just are saying that, okay, you know that, okay, you have your leading zeros or not. But again, it is never very important to maintain if you have a leading zeros or not, but I'll recommend in code you can have a variable called as leading zeros, because although with the help of indexing tight and another variable xyz, still you will be able to know if you had leading zeros or not. But this only takes twice, which means it can be either true or false, right? So it will take the 2 as the argument. So I'll say better take it to actually help it in your problem. Okay, your number has started or not, right? Now coming on back to how to solve it. Now, you know, you will need a leading zeros, you will need a I, you will need a tight, right? Again, going in back, you will need the count of even digits, the count of odd digits. So again, you will have to maintain the count of odd digits and the count of even digits. So again, a 2 variable came in picture, count of even digit and count of odd digit. Aryan, then this count will be very big. Shall I maintain that in my argument? No, it will not be very big. Why? Because your entire string is at max of length 10. So count of odd digits or the count of even digits, again, it can go to at max of 10 length, which means I can have a 1 1 1 1 1 1 at max 10 times. That's it. So again, count of odd digits you have to maintain, count of even digits you have to maintain. Again, what to do else? The number is divisible by k. So Aryan, shall I also maintain the number as an argument? No, you cannot, because you know, if you are maintaining this as arguments, you know that, okay, right now I have leading zeros, which actually will take a space of 2. My I, it can at max take a space of 10. My tight, it can take a space of 2. Now coming as odd, it will take a space of 10. Again, even take a space of 10. But again, lastly, one thing remaining with me is to actually make sure that number being formed should be divisible by k, right? So again, we'll do a simple stuff. Giving by an example, if I have any number, let's say number was 7, let's say my k is 3. So I just want next time when the next number comes in after 7, the next number, let's say it came in as 4, right? So I again want the modulo with this number 3, with this number k. So this number 3 is a k. Again, let's say I just say, okay, next time another number is appended, let's say 4, and let's say another number appended is 2. Again, I'll just do and find. So again, I just wanted this stuff mod k. Ultimately, in the end, when the number is entirely made, this stuff should actually be a 0. That means, okay, your number was divisible by k, right? So I just only want the numbers modulo operation, right? So what I can simply do is I'll simply maintain the modulo result, which means 7 mod 3 is actually a 1. Now, why it can be useful? I can simply break the next stuff down as 7 into 10 plus 4 mod 3, right? I can again say that it can be represented as 7 mod 3 into 10 mod 3 entire mod 3 plus 4 mod 3 entire mod 3. Alright, I can simply break it down. That thing I previously went and found it, right? So I can simply add, okay, I can have a 1 plus 10 mod 3. I can skip that mod 3 also, no worries, because I am ultimately doing a mod 3 in the end also. So that will simply resolve it. And plus a 4 mod 3, entirely mod 3. So you saw, sorry, it was a multiply. So you saw the previous remainder. It is, see, mod 3 is the, like mod 3. When I say is 3 is actually a k. So number mod k is actually a remainder, right? So what I'm doing is to find, as I'm appending the next number, let's say 4, right? I'm appending a next digit, let's say 4. So what I will do is I will do a remainder into 10 plus that digit, which is, let's say dig is my digit. I'll do a mod k to find the new remainder, and that new remainder will actually be carry forward. Again, for this another number appended as 2, I'll again go and find the new remainder as remainder into 10 plus this new digit, which is actually a dig, mod k, to actually find in the new remainder. And that's how I can simply keep on maintaining the remainder. Aryan, but now you are saying you will maintain the remainder for this particular stuff mod k, right? Right, but this particular, it can be at max up till 20. So for this, it can be at max the 20 locations. Now, you know, your recursion will have these states. You will have a I, you will have a tight, you will have a leading zeros, you will have a odd, you will have a even, and you will have a mod k. Cool. Now you know everything, you have sorted down. Now, coming on back to how you will implement it. Simply, as we have previously seen quite a lot of times, we will simply go on to every index and will go and ask that what are the number of ways to make and place any particular digit on that location. How we will do it? We'll simply go and start off. Again, we'll have the same example as if I take my high as 6435 for the first location. Firstly, as in the beginning I have leading zeros, I can have a leading zeros also. So firstly, what I will do is let's have our argument. Let's say name it as you have I. See, I will just name I have a I, I have a tight, I have a leading zeros, I have a odd, I have a even, and I have a remainder. And what else I need? Okay, I am done, I guess. Cool. Now it is the recursive functions arguments. So you will see in the beginning you will have nothing but, firstly, if it is a recursive function which you are making right now, let's name the function as solve or count, anything you can name it as. It will simply return what? Anything it can return. Let's imagine that anything. Let's forget it. Comes the base case. Base case is simply if it reaches the end. So I'll simply say if I has reached the end. Now end of what? End of this particular string. So I can name this string. I can convert the number to a string and pass it as a string. So I'll just say, okay, nums dot size. But remember, this nums is actually a string. So I will also be passing in the string called as nums, right? Pass by address because it's actually constant. Now, if it has reached the end, I'll go and ask. Firstly, I'll go and ask. I want to add what? I want to add my number of numbers, right? So I need to add. Okay, I have found one number, correct number, right? So I need to add that. Okay, add a 1 if you have found a correct number. So I'll simply go and check if I have found a correct number. Now, to have a correct number, what was the condition? That your remainder should be actually a 0. Ultimately, your remainder is the remaining part, and you have reached the end, which means no more digit you have. So your remainder should be 0. Your odd should be actually equal to your even, right? And this can be true provided if you see that you have a number starting from zeros. So you should not be having any leading zeros, right? You should not be having any leading zeros, because you know, if the number is itself 1 0, okay, for a number 0, I will say, and When a number is 0, I am not even counting that because the number has not even started yet. Aryan, what do you mean by that? I mean by that is that, okay, if I, let's say, I just say a number is, I am asking for the 4 digits, but I am saying, okay, it is a 0020. Now I ask you, what are the number of even digits in this number? You will say only 4 or only 2. It is only 2 because these 2 are the leading zeros which will never count off in your digits, even digits. That's the reason it was primarily important to maintain a leading zeros, because you need to get the count of actual number of even digits and the odd digits. Cool. So you will maintain the number of leading zeros. So you know, okay, actual number of even digits are actually 2 in this particular case. So here you will see number of, if the number itself a 0, number of even is actually a 0, number of odd also a 0, remainder is also a 0. So you also need to maintain, okay, leading 0 should not be there. So I'll just say, okay, my leading zeros is actually should also be a 0, which means leading, or maybe it's a false, which means, okay, I should not have a leading zeros. If that is the case, simply return a 1. So if that is the case, it will simply make a 1. I can simply return this down. Okay, it is just one way. Now I am returning an integer, so I can simply mark it as int. Now, as you know, it's a digit DP, so for sure you will have a memorization. If DP of this state, IT, leading zeros, odd, even, remainder is not equal to -1, then simply return that DP. Now comes the interesting part. Now, you know, I know that for a digit DP, what you have these locations, right? These 4 locations, which means for this location I, because you are operating on the location I, right? For this location I, what all digits you have? What is the starting? Which means, as you know that, okay, I will have many options for it. As I showed you, as I have one allocation as this 6, so I can have anything from 0 to 6. But this I made sure because I know my range was tight previously. As the question started itself, my range was tight, and I can just go and carry forward that tight to the next location. And I just explained what that tight means itself. Coming on back, I need to place some digits at the location. Now these digits will start from 0 for sure, because every person can start from zeros and it can go on to any digit, provided this any digit will be counted if I know the end, which means I know the tight. So I will go and find, okay, what is the end of my particular, what is the end of my this for this location I, what is the end? If I'll just say, if the tight is there, so for sure the end will actually be a 6. But let's say I just move on my tight, and for the next location, let's say here, if I put in a 5, so it will just carry forward a tight of 0, right? Because 5 was not the 6, so it will carry forward the tight as 0. Now when the tight is 0, I can place in a number from 0 to 9. So I will just go and ask, if I have my tight as true, so please go and find what is actually the number at ith index. At ith index, whatsoever number is there, it is actually the end. It's the maximum number I can give. Else your actual number is actually a 9. Now make sure, okay, it's actually a string, so you just subtract actually a 0 to get the actual digit number, right? So that is one thing you need to make sure while you are solving it, because you are actually iterating on a string and not a number, because you can iterate, right? Iterate in the sense going on to every index, right? Indexing as in string indexes. Now you have got the end, which means I can iterate, which means I will just go and do a for loop for digit from 0 to digit less than equal to my end, and doing a digit plus plus. So for that ith index, I can place this digit at that location. But you just saw one thing. If I place in a number 0, ooh, the number has not even started yet. So, and it actually is a valid number also. So what I can do is I can initialize my answer also. Although I can initialize with the answer my 0, which means answer is a number of possible ways. But you also know I can actually add, because what if I place a 0 in the beginning? I just continue my leading zeros. I'm just placing my zeros. So what I can do is I can just say, just continue and find and solve for I plus 1, which is the next location. Considering I am placing a leading zeros, I am placing a leading zero. Considering, again, I'm saying, considering I'm placing a leading zeros. So now you see, I have just erased it a lot, but that is what I will do. See, this part is becoming very big code, and that is a very whenever I write, I refer anything, I just make it small, so you will see it is becoming smaller, bigger, but no worries, we can actually have it as small also. So that is, again, coming on back, it's just a blunt bakwas thing. So what we did was we had our answer. Now we can actually also have leading zeros for us. Now when we are saying we can have a leading zeros, what we actually say is, okay, I'll just go on to the next location whatsoever I have, and for the next location whatsoever I have, again, my tight, it can remain same, or it can be actually 0. But Aryan, why tight will remain same? If you place a leading 0 at the beginning, oh, the number has already started, which means if I am placing a number, let's say if I am placing, okay, if I say, okay, my number limit was 6543, I place a number 0, so now I have no tight at all. So okay, even if I had a tight previously, now the tight will no longer remain. So I will just say, okay, my tight is actually a 0, because I know, okay, my tight has not remaining at all. Great, my tight is 0. What was the next variable? Leading zeros. Leading zeros was as actually there, so I'll just say, okay, leading zeros is actually a true. So I can say 1 also, and I can carry forward that leading zeros also. No worries, I'll say 1. Odd, it will still remain the same, even will still remain the same, and remainder will still remain the same. That's how you can, okay, just say, okay, I am just carrying forward that leading zeros. Number has not even started. But with this, you now, Aryan, why you carry forward leading zeros? By this you will just make 0 0 0. No, with this what will happen is, okay, you will have a number 0 itself in the beginning, and with that you can just go and try for the next numbers possible. Now coming on, for every digit whatsoever I have, I'll just go and ask, hey bro, firstly let me know, okay, I will have a condition. If I have a leading zeros, firstly, let's say if I don't have a leading zeros, okay, but if I have a leading zeros, so for sure, I cannot place a 0. So please start my digits which are not equal to 0, right? What if I have a leading 0? Okay, I'm just saying, okay, I had a leading 0. I can start from any digits whatsoever. Right, it's not a 0, because if I have a leading 0, I cannot place a 0 again. That will actually come again and placing a leading 0 again, right? So I don't want to place a leading 0 again also. So I'll just place another number here from 1 to that digit, any number. So that's actually a digit which I will place here, which should not be a 0. Okay, that's one case. If I have a leading zeros, what if I don't have a leading 0? Can I place anything? Which means, okay, I have a number, let's say 2 here. Okay, my leading zeros would have been exhausted already. So now I can place any digit. I can also place a 0 here. That's correct, right? Yeah. So I'll just say, okay, or your leading zeros is actually a 0. So now you can place this digit. Here it will come in. Okay, if I have a leading 0, I can place in any digit from which is not 0. Here, if I have no leading zeros, I can place in any digit which is this, in this range. Okay, cool. Now I will simply add that to my answer, and I'll just say, okay, I know that I will simply solve it. Now for the next index, which is I plus 1, now the next thing I want is actually my t, but that tight, I will need to get the new tight. Okay, because if I am placing a digit, what is a new tight? So I'll just have another variable. Before that, I will just find, okay, what is the new type. I'll just go and find, okay, my new type is actually nothing but my current type. Okay, my current type, if it's actually a true, only then I will carry forward the type, right? So if I have my currently I am type, and the current digit which I am at, sorry, it will be at this location. So the current digit which I am at, if it's actually equal to my that digit which I wanted. So you saw, if this digit 6 and this number 6, if it's actually same, so I need to carry forward my type. So I just ask, if my current digit, firstly I just carry forward, which means I just have that 1, and if this current digit, if it's actually equal to my nums of I, if this is the case, so it is my new type, and that will be a 1. If it is not, if it is either, if I'm not carry forward my old type, or basically I'm saying, okay, if it is not equal, then I'll simply say, okay, my new type is 0. Now again, I have got the new type, so I just simply can place in my new type here. Okay, cool. My new type is placed. My leading zeros, again, my leading zeros, I know that my leading zeros here, you saw I had a leading zero, but I'm placing a digit. Here I have no leading zeros. For sure, the leading zeros will actually be a 1. You can also place in the correct leading zero, but yeah, it will actually become a 1, which means, sorry, it will actually become a 0, which means you will have no leading zeros at all from now onwards. Now again, odd. So I'll just get, okay, what is a new odd? So I'll again have another variable in this. What is the new odd? Again, simply I'm just asking what is the new odd count. Again, same thing. What is the old odd count? Plus, if this number which I am having, which means if this digit mod 2, if it's actually odd, so it will simply have a 1. So it will simply say, okay, it is a new odd count. But Aryan, you also want the new even count. Again, for the new even count, I'll simply go and ask if this digit mod 2, again, if it's actually a 0, so if it's actually a 0, so simply add a 1. But number 0 mod 2 is actually again a 0. So will you add for every zeros? No. For leading zeros, you will not add. So you will say, okay, if this is actually a 0, which means the number is even, but also it should not be having any leading zeros. So I just say, okay, if the leading zeros is actually again a 0, only then I will just add that even digit in actually my even count, and that I can pass in. I'll pass in my new odd count, and I can pass in my new even count, right? I have passed in my new odd count, my new even count. But Aryan, one thing is remaining, the remainder part. So again, for sure, you saw I just did one thing, remainder into 10 plus my new digit mod k is actually my new remainder. Although you can also place in, okay, I will have my new remainder as nothing but remainder into 10 plus digit mod k as my new remainder, and that's the new argument which you will pass in your new function. Cool. And that's, you can simply get it solved. That is the entire logic of your entire recursion which you will actually implement. Cool. Let's quickly jump onto the code and see that it's nothing but exactly same of what I showed you. Firstly, you will just convert your numbers to actually the strings, right? You will convert all your numbers to actually the strings you wanted. Firstly, can we please smash that like baby to 70 likes? Just one more, that would be super great. And now coming back, so I just had my low and high, so I know I need to get the count from 0 to high and 0 to low minus 1 to actually get in the actual numbers from low to high. So I just converted my low minus 1 to actually a string called as s low, high minus 1 to actually a string called as s high, and also I just got the k as a global variable, because although I can also pass this as an argument in my function, but yeah, it's nothing but a global variable which you can define. Now coming on back, you need to find the answer from 0 to s high, because right, s high is nothing but the string converted in the high, like high converted as a string. So you will just go and find the answer for S high. Let's name it as maximum count, because it is nothing but from 0 to high. What's the count? From 0 to low minus 1, what's the count? Simply subtract that. Again, you know, you are calling the recursive function again and again. So simply memset your DP again and again. Now, that is one thing which you will find. Your main task is now the recursive code. That will be exactly same. I will have a nums, which actually a string of my number. I will have a type initially made as 1. I will have the indexing as 0, which means that I'm going on to the string at every index initially as 0. I will have the odd count is actually a 0. I will have the even count is actually a 0. I will have the initial remainder as 0. And initially I have my leading zeros. I will make that as true. Now I can quickly go on and move forward. I'll just go and say if I have reached my num.size, I just go and ask if my remainder is 0, if odd is equal to even, and also I have no leading zeros, which means I have reached my correct end. If I have a correct end, simply return a 1 for this particular thing, else 0. Simple memorization. Tight, I, odd, even, remainder, leading. If it's not -1, simply return that. I found my end by simply saying if my tight is still there, then it will actually be the number, else it is actually a 9. Again, I found my answer by saying, okay, if you have a leading zeros, simply go and again say if you have a leading zeros, and if you are actually continuing that leading zero, for sure your tight will go on, like it will go and it will not come back. You will go on to the next index, which is I plus 1, odd, even, remainder, it will remain same, and you are maintaining your leading zeros because you are actually having that leading zeros as carry forward, so you will actually maintain that as true. Else you will just say okay, if you have no leading zeros, so your new answer will be initialized with actually a new 0. Now I will go on to every digit from 0 to end I showed you above. I will go and find my basis of my tight. Now I'll go on to every digit. Firstly, I know that okay, I need to find my new tight on the basis of my old tight, and if the digit is actually equal to my that particular nums cut digit, if it's same, okay, I need to carry forward my new tight. I'll just go and find the new odd plus digit mod 2. I'll go and find the new even. It is nothing but even plus if it's actually a digit mod 2, and for sure if the digit is actually more, or if it's having no leading zeros, I'll simply go and say simply add that in my even, add that in my even. Now I'll just simply go and ask if you have no leading zeros, okay, simply use that digit, or if you have leading zeros but yeah, that number is not a 0, then also you can simply add that digit. Now when I say I added, I simply say I'll go on to new I plus 1. I have the new tight, I have the new odd, I have the new even. My new remainder is this particular thing, is remainder into 10 plus digit mod k, and for sure I will not carry forward my leading zeros, so I'll go on and say a false for my leading zeros. And that is by I can go on to every digit and find my answer. Simply before returning the answer, which means the number of digit, simply make sure you assign to your DP, and that's how you can simply get this solved. Again, the complexity is nothing but O of 2, 12, 12, 12, 20 into 2 into this particular 10. And that's how you can simply get this solved. I hope that you guys got it. That was pretty much it. Thank you so much for watching. We will end the stream in a meanwhile, but that was 6D DP. So like that is, see, in digit DP, the states never matters because it's nothing but a simple recursion where you are actually more focused on, okay, I have to use these states. It's just memorization which you have to do. The number of DP states hamper us when we actually start thinking in the bottom-up approach. But in the top-down approach or the recursive approach, states never actually hampers our thinking. It actually helps our thinking, right? Cool. Leading zeros part not getting, brother. Can you explain it with an example? So basically, see, leading zeros are just important. Firstly, as I showed you, leading zeros are firstly very important to know. Let's say if you are just having this number, right? You are having this number 6435. So I'll just go and have this number 6435. You have a number 6435, right? It is the high. So you need to make a number from the range of 0 to 6435. It is a range which you have to make. So you will have 4 places to place in the digit. Now, if you start placing a number, let's say here at this location, I can place a number 0. I can also place a number 1. I can also place a number, let's say 4, yeah, 5, yeah, let's say 6. I can place a number 2 also. Now, if I place a number 0, is it same as placing a number 2 at 6? No, right? When I place a number 2, firstly, if I am placing a number 0, initially my type was 1. Initially my type was 1. Initially my type was 1. When I'm placing a number 0 as in the beginning, I will say firstly my type has become a 0, which means I can now place any number. Again, here also my type has become a 0. I can now also place any number. Again, my type has become a 1. Why? I cannot place any number. When I say any number, I can place a 9 here, but here I cannot place a 9. I have a type, so I can only place a number from 0 to 4. Now, it is the concept of type which is actually being used. Cool. It is one such case. Here you saw I can place in any number from 0 to 9. Okay, I can place any number from 0 to 9, but the number has started, which means you know your leading zeros are no more, which means here the leading zeros variable is actually a 0, right? Here it is actually a 1. You have a leading zeros. Here also it is actually a 0. Cool. But okay, this case, last case is gone, already gone. Understood, right? How your type is actually impacting your numbers. Here, if the leading zeros are actually gone, you can actually know, okay, your even count is right now a 1. 2 is there. But if you place a 0 here, as you know, the number has already started, your even count will become a 2, because it became 2 only and only because you know that, okay, your leading zeros was actually a 0, which means you had no leading zeros, which means the number you are placing is not at all a leading zeros. This zeros is not a leading zero now. It is actually a number which is after your leading zeros has ended, which means the actual number has started already. So you need to know if your number has already started or not. So to know that if your number has already started or not, you need to have, okay, if this is done or not. So firstly, the first primary use case was, okay, you need to know if the number of even numbers are there or not. Now, again, coming on back. Again, I have options to place a leading zero here. Now, if I am saying I have a leading zero, I can again go and start with any digit whatsoever. Here again, the even count is again a 0. Even if I place a 0, again the even count is 0. Here if I place a 4, now the even count is actually a 1 and leading zeros actually become a 0 because the number has actually started. So when you are concerned about the actual number starting, okay, the number has actually started or not, you're concerned on that part because your answer is impacted on the concept if your number has started or not. Then only you need to have a leading zero variable because it will make sure to make you know that, okay, your number has started or not. Because if a number has not even started, you cannot apply operations like, okay, what are the even numbers, what is the frequency of some XYZ number, all that stuff. Let's say if I start asking you what's the frequency of every number count, if it's actually important or not. So you need to maintain the leading zeros also for that case. Cool. I hope that Pranay, he got the concept of leading zeros, that why it is important, how we actually maintain that. And as soon as I start off any number which is not a 0, and earlier also I was not having any leading zeros, sorry, earlier if I was having a leading zeros, and if I start off with any number which is not a leading zero, which means which is not a 0, for sure my leading zeros has ended now and I will no more carry forward my leading zeros. Cool. We'll end the stream in 3 minutes. Can we please smash that like baby to 80 likes? That would be super great. Thank you so much for watching. सुबह जल्दी उठना है. Have to make video for tomorrow also. आज luckily we had a live stream because I came in very late, very late. It was around 10:15ish. I came in back. That then I saw problems, all that stuff, and then I was able to deliver it. But cool. Thank you so much for watching. मैं आया और आप जा रहे हो के जी. When's the next live? it is tomorrow morning. Good night, brother. Your solutions are very helpful. Thank you so much, Arjun. Bhaiya, when should we start preparing for aptitude and CS fundamentals? Around a month before the actual interviews. You should one time you must have gone through it at least. Now when I say 1 month, it should be okay. You know the basic fundamental, like you know the basics. It's just that okay, you're just revising the interview questions of DBMS, oops, all that stuff. It should be 1 month prior to actually the interview or the placement season starting. Cool. Thank you, Aryan. Managing work and doing live streams every week is not easy. Thank you so much for amazing effort. Thank you so much, Rohan. And thank you so much for the discussion. It's really helping a lot. Thank you, brother. Thank you so much. Thank you so much for watching. See you guys next video. Until then, goodbye. Take care. Bye bye. Again, thank you so much for turning in. जाते आते अगर 80 हो जाए तो अच्छा होगा, नहीं तो भगवान भला करे सबका. Cool. Bye tata goodbye. I know it had been read, तो थोड़ा buffering हो रहा होगा आज, but yeah, that was pretty much it. Again it's buffering. क्या होगा यार मेरा? Cool. Bye tata goodbye. I should end now यार. Bye.